Hello and welcome.
Hello.
My name is Mathias Claußen.
And my name is Jens Nickel from Elektor magazine. And we are talking today about
embedded development with PlatformIO. And we have chosen some backgrounds for that, some interesting things you may like to know about. And also we are doing some live coding and some live samples.
That's interesting, yes.
Yeah, so what can go wrong with this? And yeah, how hard can it be? And with these wise words, let's start with the presentation and PowerPoint slides we have prepared. So let's move over to that one. So development with Visual Studio and PlatformIO. So what we are going to cover today is what is Visual Studio Code, what is PlatformIO, with these, how to start a new project, how to compile and upload code, and also how to use those for debugging. Yeah, so what are we using today? So if you like to follow us and may do it also at home, we have the M5 stack, the ESP32 M5 stack in the gray edition here. This is the one on the desk. We are using the Pico experimenting kit you can find at the Elektor store, because it gives for the Pico a good bang for the buck in terms of peripherals.
And that means already that PlatformIO is a multi-platform environment.
Yes.
Of course, you can also find this in the Arduino IDE. There are also a lot of microcontrollers. So is it comparable, Matthias, a little bit?
If you talk from the editor and the benefits you get with Visual Studio Code, it's like preparing a rocket with a bicycle. So the Arduino IDE, it's not the best editor in class, to say. And Visual Studio Code, with the editor providing underneath and PlatformIO sitting on top of that, it's a full different story in terms of coding. And yeah, also you will need, as usual, some USB cables and some jumper wires. So that's hopefully something you will find at home. So while we are started talking about it, what Visual Studio and PlatformIO is.
I know, for example, Visual Studio, but Visual Studio Code is a complete different thing.
Yes, Visual Studio Code is based on the Atom editor. The Atom editor is invented or developed by GitHub. GitHub was bought by Microsoft. And so they took the Atom editor and added their kind of IntelliSense, the autocomplete, from the Visual Studio, for example, code highlighting, syntax highlighting. And they not did that just for one language. So you have here a whole bunch of languages that are supported within Visual Studio Code, like C, Python, HTML, JavaScript, Java, C#, also hardware description languages like Verilog, VHDL. There is a plugin, or at least a syntax highlighting for that in the editor. So you have a really, really nice editing experience in the first place. And this is what just the Visual Studio Code is doing. As mentioned, you have also autocomplete. So you just type a part of your function, and then you get a list, and you can tap how to complete it. It makes typing a lot faster and less error prone. And for the Visual Studio Code, there's a marketplace. So you have a lot of third-party plugins and add-ons from all over the community to extend it. And
it's free?
It's free.
Yes.
There is one caveat. We come to that later.
Yes.
The good thing is it runs on Windows, Linux, Mac, and on the Intel and also on the ARM side. So also on an M1 Mac. That's not a problem. And also on a Raspberry Pi. And that is, if you are starting with the Raspberry Pi Pico, in the manual you'll find how to set up Visual Studio Code on a Raspberry Pi 400 or Raspberry Pi 4, for example.
To program it, the Pico.
Yes.
Okay.
So that's quite nice. And while this is interesting, the Visual Studio Code is open source. It's mid-license, so it's like do whatever you want. The interesting thing is you can get the precompiled binaries, and they are not free open source software licensing compatible. That's closed source blobs.
Microsoft built in a small thingy.
Yeah, there's telemetry built in. You can disable opt-out it. And there's also VS Codium. VS Codium is the Android equivalent of the vanilla builds. So they take the mid source code from the Git repository and build it just plain vanilla, no added telemetry. There is, it's fully built from open source. One thing is a few plugins and a few things in the marketplace are not fully compatible with that licensing scheme.
Okay,
so
I see.
as private user, if you don't care, well, that's
You
up to
take
you.
Visual Studio Code. And for the diehard nerds, they take maybe the Codium.
Yeah. So the next thing is, what is PlatformIO?
Yes.
And it's a vendor-independent development environment, not just bound to embedded. You can also write whole applications in Qt, C, or whatsoever for Windows, or even for your Linux running on a Raspberry Pi. Cross-platform, so pops on top of an editor of your choice. So it's not just Visual Studio Code that it's supported. It's also, there's a whole list. Eclipse is one of those. JetBeans, Sea Lion is a supported platform. So it it sets on top of those, uses the editor underneath for all the nice editing stuff, and then adds the embedded development or the development parts with all the nice benefits it brings.
Mm-hmm.
Like you have management for certain platforms, so you're not just bound to the Arduino framework or Arduino stuff. You can also just use the bare metal C libraries other vendors provided, and are supported in PlatformIO. You have a library management. For example, if you do an Arduino project, you have this list like, okay, use that library from that author, and that's it. No certain version you can point to or certain release you can point to, because in the past, every time you updated one of those libraries to another version different than the author intended, it may break fully your code.
You come in trouble, of course.
Yep. And what's also interesting, you get debugging support in terms of multi-platform debugging support. So it doesn't care if you're on an ARM, on an ESP32, on a RISC-V MCU. As long as there's support for the debugging devices in PlatformIO, you can use those.
So it abstracts from the platform, from the hardware. You always have the same environment.
Yeah.
The same IDE.
And as mentioned, you have a multi-vendor support. So if you look at this list, you can see who's in there. So we have ARM NXP, and you have the RISC-V guys with NetST, the Teensy guys with the Teensy 4.0, 4.1 NXP CPUs. There's still Freescale in it. It's not NXP. You have also support for some FPGAs, the latest stuff. To a certain level, Nordic, for example, for their Bluetooth chips, or Bluetooth Combi MCU chips, Atmel, of course.
And you can even make programs for the Raspberry Pi and even Windows and Linux programs. That's interesting. So it's not only in the embedded world, it's also for PCs.
Yeah, or embedded Linux devices. You can use it also. So it's quite nice. And an interesting thing, you also have a built-in serial monitor. So, I mean, the Arduino IDE has it also, but it's in there. It's nice to have it.
Okay.
And as said, also the multi-framework support. You can, for certain platforms, choose if you want to go the Arduino route, if you want to go bare metal, or if you want to use another supported framework or another supported ARM choice. And what we had talked at the beginning in Visual Studio Code, there's the telemetry, and this is how you can get rid of it, or at least turn it off. Not fully get rid of it, but you can turn it off. Inside Visual Studio Code, just go to File Preferences Settings, search for telemetry, and set it just to off. So it should not transmit any telemetry at all.
One question, I think you prepared these sheets on a GitHub place, so the readers can download it.
The presentation slides are currently not there, but the code we are going to use is already there.
Okay.
We will come to that soon. So, download links in demo projects. So, we have that put to on our GitHub account. So you can find in this link the repository for the webinars. Also here you have the link for Visual Studio Code if you want to try that out, and also PlatformIO. So for the first part,
one question left. PlatformIO is also free of charge?
Yes, free of charge. You can use it. There is a commercial service behind that, but that's beyond the first embedded steps.
Okay.
So even debugging, writing code, compiling, uploading, it's all free.
And now we want to see if it's really that easy as, for example, the Arduino IDE.
Yeah. So let's do a small demo project for that. What you just need, Linux, macOS, or Windows, x68 or ARM, so you can use a Raspberry Pi for that if you like to. So with a Pi 400, it's quite nice, and you can work with that, but I would prefer a currently full-blown PC with enough power. Visual Studio Code installed, PlatformIO installed. We have here the M5 Stack Development Kit that's currently out of stock. And for the moment, I'm not sure if that will get back in stock. So that's the sad part for that. An alternative for an ESP32 in our shop, you can use the ESP32 based boards, for example, from Joyet, the Node MCU. As the Espressif Pico kits, they are ordered. They are somewhere between the manufacturer and us. So you may know transportation is at the moment not as easy as it used to be. Next slide. Any questions already from the chat? No,
I don't see any.
So what we are going to do, generate a new PlatformIO project. We can initialize it as a Git repository. We will add a few new libraries to it, add some code to it. We'll upload the project, and I will show you, that's for maybe your later projects, how to upload the flash file system. So if you're having a web server, the usual question is, on the Arduino IDE, you have these upload flash file system, how to do it here.
So there's really one tool which makes it all?
Yep, and it's not perfect. Yeah, still some things to do.
I should switch to your notebook.
Yep. So I've prepared the project, so I tried that out. What I now do is something every presenter will strictly advised against, doing something live, especially a new software project. What you can see here is the Visual Studio Code in dark mode, preferred mode for me. You have here this little end you can click on, quick access to open a new project. You have here the ability to name it, test2, and you have a set of predefined boards. And the M5 stack, I know, is one of those predefined. And now it comes to the point, we have to switch the camera to full screen, to AV mode. Otherwise, nobody would.
And it seems to be mirrored.
I'm not sure why it is, because I
can we maybe switch it in the OBS?
Oh yes, there's a mirror, mirror mode. Ooh.
It's here, I think. There you can rotate it. Or mirror.
Wait.
Right mouse click. Transform, yes. Flip vertical. Yes.
Okay.
No. Still.
Not flip vertical, it's then flip. You open the welcome page. Can do that again. So, non-mirrored. You have the little end on the side, hidden here. Or, go to PO Open. you got to the, let's make that.
I think readers say it's now mirrored.
Then we have to do that backwards.
I'm not sure what's happening in Click Meeting.
Okay.
Let's get it back. So we see it mirrored, but I think the horizontal. Okay, strange. We see it the other way around, but okay.
If the viewer sees it the right way. Okay, now it's upside down. It's how many rotations can we get? And
ich glaube, vertikal musst du nochmal machen.
Okay, now it's, yeah. So
now it's okay. Good.
Back to the right mouse. Yeah. Welcome to PlatformIO. You can just click on New Project, name it like you want, something you would like to find back. You choose your board if it's supported, and it's an extensive list of boards in there. Here you have the framework you can use. That's the Arduino framework that's supported, or you can use the Espressif IT development kit. So more or less.
So you have exactly the same Arduino libraries, the Arduino commands, but you have a different IDE.
Sort of. So
and a better syntax highlighting.
Yeah, definitely. So what has now happened? The project is prepared. You have here your test2 folder that's on your file system. You have a structure for libraries you can add. You have a structure for your source where your main CPP resides, the C code. You can look into that. And it comes also within PlatformIO INI. And this INI, it tells PlatformIO which CPU type or family you are using, which board you are using, and which framework you like to use. So for the M5 stack gray, that's all set up. What we are going to do, let me switch back to the slide. We want to control this VS WS2812B stripe. There's currently a demo project running on it. So our problem is, first, we don't have code. That's not an issue. I know where I parked it, and we need a library for that one. So how to get that?
Matthias, it starts a little bit earlier. How can you come to this screen, to this black screen? I think you first have to download Visual Studio Code.
Yes.
You get it on some Microsoft webpage, of course. Then you have to install an add-on for Visual Studio Code, and that's PlatformIO IDE.
You can, if you have fired up Visual Studio Code, you can press Control-Shift-X.
So Platform IDE installs as a plugin for this Visual Studio Code editor.
Yep. Then you get into the extensions, so the marketplace. Type in platform, then you will see Platform IDE.
Yes.
Click on that, and then you will here have the point install.
So it's really a matter of some clicks to get this system running.
Yes.
And then you just choose your platform and your framework as you have shown.
Yeah. So let's get back to that one. So our project, we have it back. So, and then you can go all through the steps with all the things around it.
And you do not have to program this platform INI yourself.
No,
I think.
I can add things to it.
You can.
But that's more for the, I think we won't fit it in this webinar. Yes. I think we are just way back.
A sort of scripting language.
The INI tells certain properties of your project. So in your INI,
a configuration file.
Yes. And the configuration, so in this ini file, you can also have multiple configurations for one board, which is really interesting. If you, for example, have a board where you first like, for example, to use another CPU frequency in the first place. So you can, for certain boards, define which CPU frequency you would like to use or which flash layout you would like to use. For example, for the ESP32, how many flash will be reserved for your file system, where you can put your web files, and how many space will be reserved for your application code.
Okay. So that's for the bigger platforms.
Yeah, the ESP32 can that also.
Oh, okay.
We will come later to the Pico. I hope we will be enough in time to do so. For example, there you can say, okay, I want my Pico to run at 125 megahertz. I want my Pico to run at 250 megahertz. I want to have a certain amount of flash reserved for a file system. I don't want to reserve any space for a file system at all where I can put files. I just want for pure program flash. You can also say at that point, I want to build a program that just runs from RAM and not from flash.
Oh, I see.
And that's quite easy then to change the configurations, also for debugging. So you can build one configuration that's just for pure compiling and uploading, and you can have one configuration that's also for debugging. It's quite nice, but
okay.
Yeah. So this is the basic project set up. So there's nothing inside. To compile it, you have down here. It's hard to see. Sorry. And check mark. Hit on it. That will build your project. So it will get all the requirements for that one.
But at the moment, we just have set up and loop, so it will do nothing at the end.
Nothing is happening. What we need to do is to put some code inside.
Yeah.
And for that one, I will borrow some code from the project that's already uploaded. Put it in here. And now it will be really unhappy for some reasons, because this project doesn't have the Adafruit NeoPixel library installed. What to do? Install it. So we had...
Let me guess, just a matter of some clicks?
Sort of. Sort of. You can... There are now two things. If you hit now compile, it will say, hey, I can't find the header. And you can search in the library also for the header file. So it will split out a set of libraries that may have this header included, which is quite nice to get an idea. Head over to libraries. Adafruit NeoPixel, click on that. Then you have here, you can select which version you like to use. So if you know there's a version which has a bug inside,
you can take an older one.
Yeah. You just say add to project, then you select the project you like to add to. Just to. Then it says add. Takes a little while. In this case, it's quite fast because it's already downloaded. As I did it for another project, but it will download the library in exactly that version.
And will Platform IDE detect if I take a too old version when functions are missing?
No.
When at compilation.
At compilation, it will say something is definitely wrong.
Yeah.
But here, it's now added, and you can see in the PlatformIO, and it now added the line libdeps. So it says, okay, this project has library dependencies. Exactly this library with this specific version is needed for this project. You can also change that later to you need at least this version. Or you can also say, I don't like to have that in that version for reasons.
I see. And then a Platform IDE will check.
Yeah. For example, if you say, okay, it needs version 1.0.3 and you have 1.0.2 or 1.0.4, it will say, hey, I need to download for this project exactly this library. And the nice thing is, if I now hand over this project, for example, to you, you don't have this library installed, Platform knows now exactly what this project needs to compile. So it will download the library in that version, put it to that project, and you will have a running executable at the end. So that's the idea.
Can you give me also the whole project with all libraries integrated?
Yes, that's also possible to do so. but usually not required because this makes the project a lot smaller because they don't have to provide every time the library. And then we can hit compile. It will take 1 or 2 seconds. The mirror image is still strange.
Yeah.
At least to look at from outside. It's like looking from the wrong side of a monitor, from the inside to the outside. So it now says it's compiled. Then you have these little go arrow that says upload. Just click on it. It will execute the expressive uploader. It's now writing, resetting, and that's done. I mean, we should have uploaded the empty one to show that it's really uploading, but yeah, that's what it is definitely doing. So that's all the magic you need to get started.
Okay.
To show something interesting, this is the syntax highlighting I mentioned. So let's say serial, and now you get all the functions of that class that are available. You can move through it. Let's say read. And also you get a preview of what the function will do. And also if you have more parameters, more parameter types, you will also get a list of what you can throw into that one to make it work. So it's really quite nice. And also if you do something stupid, you will also get notifications at compile time. I mean, this is now not correct. I should get an error. And I said never do stuff live. So
and there it is.
Yep. And now it says, hey, there's an error. Hit control, click on that. Control click. And your cursor will jump to the appropriate line where it says the error is approximately detected. Okay, yeah, that's how you code and upload. Next thing is, what I like to show is how to get the web pages or the Flash file system uploaded.
Yes.
I think we have to hurry a little bit. For that, there is expected to have a data folder. And I'll switch to a project I prepared. So
yes, for the background of this, if you want to equip a microcontroller with web pages which are offered to configure it, for example, as you did it for the Elektor weather station.
Yep, for example.
Yeah.
Or the CO2 meter.
So you can put in complete HTML with some JavaScript.
Yeah. And the CO2 meter is also using PlatformIO with all these techniques also. We need, in this case, we needed to use the terminal. Problem here is the way the project is currently set up. For the ESP8266 is not a problem. For the 32, at some points, the action upload file system is missing, depending on how the project is created. It can happen sometimes. It's PO run T. It's PO blank run blank minus T upload FS as command. This will build the Flash file system, will do the upload, send it to the ESP32, writes to the chip, and after that, you're good to go. So quite easy. Usually there's a menu point, but at the moment, yeah, something is not quite working as intended. Okay, that's it for the ESP32.
Okay.
I think it's quite easy.
Yeah.
I don't know what your opinion is. I mean, I'm doing that now
I will consider to step into from the Arduino IDE to Platform IDE, definitely.
Yep. The next thing we will like to do. Yeah. So one thing is the ESP32, and that's supported for a long time. The other thing, which is currently interesting to develop for, is the Raspberry Pi Pico with the RP2040. You have the option to use Visual Studio Code and the C SDK, the Pico SDK, or you can go for the Arduino IDE and the Arduino framework. So you have on the one hand the Arduino framework with all its benefits, with all its libraries, and a terrible editor.
Yeah.
And you have a really nice editor in terms of Visual Studio Code, but with the Pico SDK and no direct Arduino framework support. What to do? Make it work. So PlatformIO and Visual Studio Code do support the Raspberry Pi Pico, so that's working. And yeah, let's head over to that point. Presentation mode. Let's see where we have stopped with that one. Yeah, let's get over to that one. For the ESP32C3, if somebody asks, yeah, there is support, but just for this one dev board and just for the expressive IDE, and the Arduino framework is insufficiently added by an currently external Git repository.
That's the new one with the RISC
with
5 core.
Yep. So the A266 replacement. For the Pico, it's the same. So we have official supported frameworks and we have unofficial supported frameworks. So there is a community that's adding support for frameworks that are currently not officially in the build.
Yeah, so there's unfortunately another issue with PlatformIO because it's hosted by in the Ukraine.
The R&D team is or was there. So they currently don't tell anything about that. It's just like the R&D team is Ukrainian based. So they have currently other things on the to-do list than that. But it's still worked on. So, with the Raspberry Pi Pico, we come into another weird situation. For the Arduino, we have two frameworks. For the Arduino framework, or for the Arduino framework support, there are two software sort of frameworks around. That's one, the official Arduino framework from the Arduino guys for their RP2040 Nano Connect. That's based on the Mbed framework, the ARM RTOS. We have currently, sadly, no bare metal support for the Pico SDK officially. And we have no official support for the Arduino Pico framework by OLF Philhauer. And the thing is that the last framework is those that are used by most third-party board manufacturers. So it's a weird situation that the framework, not from the Arduino guys, is the most used framework for Arduino RP2040 based boards.
I see.
So it exists unofficial support for bare metal SDK as also for the Arduino Pico framework. And currently debugging is a little bit hacky. And debugging in terms of we connect a real debugger to it and can stop the MCU and look inside. But we will come to that at the moment. So to get the Arduino Pico framework, we have to hand edit the PlatformIO. So we start with a Raspberry Pico project in the first place, and then add a lot of lines, remove everything that's inside, add a lot of lines inside, and this will make it work, sort of. It can. On my machine, in the end, it has worked. It took up to 25 minutes until everything.
Okay.
Can we put it on hold? So, and yeah, can work, has not, but that's the way to do. So it took the Visual Studio Code approximately 20 minutes to pass all the downloaded files and get the code in the right place and stuff like that. So be patient. But in the end, it works, and you can code your Arduino code for the RP2040 with syntax highlighting, auto completion, and also the ability to debug. Uploading is not a problem. You can have multiple configurations, so I think it's worth the trouble. So 19? 20. Yep. There's one thing if you're on Windows. So Windows and USB devices are sometimes not really friends. And if you have a USB device that's not supported within Windows built-in driver, and the RP2040 boot interface is also one of those, you won't see an exclamation mark or something like that, but there is a part that needs to have an Zadig driver installed. After that, everything is running smoothly with PlatformIO. You can upload it. You can upload code directly to the Pico and all stuff like that. So yeah, just hit over to the Zadig page, download it, and yeah, then open it, connect your Pico in boot mode, install the driver for interface 1, and that's the magic to make it work. But that's something you have to look up, and somebody has to tell you in the end. And one thing that's really interesting that we have here also on the desk prepared, let's put that aside, is the Raspberry Pico. This one is acting as a debug probe for the installed Raspberry Pi Pico on this board. Okay. That means you will use that to upload code. It's quite interesting to do it that way if you're using this in USB host mode, because you can attach still USB mice, keyboard, or whatsoever. I see. And have a nice way to upload still code and try and figure that out. Okay. Besides unplugging bootloader, so you don't have to send the board in bootloader mode. You can upload without forcing that into bootloader mode also. Okay. You know, so you need to have a supported debugger, and the Raspberry Pi Pico is the cheapest one you can have. You can get the firmware on the Raspberry Pi site if you know where to look for. So follow the link. Just upload the UF2 file, wire as follows. So standard wiring, and you're good to go. You will get the debugger, and you will also get a serial interface. So, but as said, has some issues. Currently a little hacky solution, but they are working on that. For the debugging on the Windows side, you have the OpenOCD debugger, so the Windows part that talks to the debug probe. You need a custom compiled one. It's available, so in the PlatformIO, the lines are provided will do this. And yeah, PlatformIO can become slow or throw errors as all the downloaded files from the external repository are. It doesn't like it really. Give it some time, 20 minutes, 30 minutes to settle down. But in the end, you are able to really debug Arduino Pico projects that you have written with the Arduino framework. I see. So, and yeah, for this one, a little time for a demo. I won't set up now this as a new project because I think we don't have the 20 minutes. No. So I've opened the project, and we now are in the PlatformIO INI. And as you can see, it looks a little bit different than the basic one we have seen for the ESP32. You can see the platform packages. You can see library dependencies that's used for this board. And you can see that we have one set that's just for compiling and uploading, and that we have also 2 sets for debugging code. One that will compile as a run executable, so not stored in Flash, and one stored in Flash. So what we are now going to do, set that to debug Flash. We now go to the run and debug, hit the debug button, and we'll see what's happening. This morning, nothing will happen because we have one little issue. You should plug it in. It's not wireless. Get that off. So the debugger has connected, and you now see something you usually don't see. We have stopped at the first entry. So here we have the first function where the debugger was able to stop is the point where we set the clock for the Pico on this board. So our target board. So at this point you can check, for example, what parameters are passed, if they are still there. And we can hit continue, so it will run. And we can hit pause. And then you will see where the processor was at the point where we hit pause.
Okay.
You can go to your source code. For example, here, our project, and the main CPP. Like line 88, I want that if the processor comes to the place that the debugger will stop the CPU. Wait a second, it will do that. And now, for example, we can look at what value the variables will have. We can single step. So step into, so it will step into the function as good as possible, read the value, return the value. So you can walk step by step through your Arduino code. And I think that's really interesting.
Yes.
Can also help to figure out some problems where debugging with a LED or a serial port may become difficult.
Yes.
You can also set breakpoints and interrupts. So it's really interesting to see if that's running into your interrupt routine, if the right core is doing that. So, and also what state variables are set. One thing that doesn't work, and that's a known issue, you usually have the ability to see all the registers of your peripherals, how the pure state machines are set, what values are in the register for the serial port or the USB. Sadly, that is currently broken. They know about it. They will hopefully fix it. And for the moment, you can live without it. But here, now you have the ability to go step by step through your code, your Arduino code, and see what's going wrong. Or not. So I think that's quite interesting. Questions from
we have the first question, I think, for today. Dump memory also possible?
Yes, not a full memory dump, but there's a memory viewer. So we can do 2 things for memory. First, we can add a watch. How was that? One second. There's a more convenient way to do that. So you can add a watch for your variable. And if you want to go into memory, you can do that. So you have a kind of memory viewer, and you can add a memory location where you like to look at. But I'm currently not sure where memory should be located. No idea if that's a valid address or not. It's 2000. Nope. But in theory, that's not a problem. So you can access all peripherals or memories inside. So that's generally not a problem.
Okay.
More questions?
No.
Yeah. Sorry, but I don't have a memory map in head. So
Thomas is also asking about stack pointer view.
I know what he means. No, haven't seen that. I mean, the call stack, yes, it's there. So you can see the call stack. He wants to have that. And if he wants to see the CPU registers, so R1, 12, and the other stack pointer, link register, program counter, yes, they are also there. We can, let's do the step inter. So I think what he may means yes, you can see the call stack, but it's not fully 100% working. There are a few things that make that not happen in Flash. If you go to RAM, yes, it's kind of a linker script thingy at that point. Basically, it should work, but currently not fully supported.
Yeah, 10 minutes to go. About 10 minutes.
Yep. Before it gets too long, and I think there will be now a million questions for this, or a million question marks at least. I think we will do the Q&A or questions for this point.
Okay.
Go to presentation mode back. I think we have a little bit of the presentation.
Another question, are breakpoints also possible in Flash?
Yes, so we are running out of Flash, so we can set break. Oh, that's a good one. You can set a breakpoint with a breakpoint unit of the MCU. This breakpoint location can be in Flash. If that's like having more breakpoints than the CPU supports, there are methods to do so. No, that's not supported with this combination. Yeah, so that's if you're running out of hardware breakpoints, that's it.
Yes. Okay.
Yeah. So
at the moment, I don't see any more questions. So this is now the timer. There's another one, also from Thomas. How many hardware breakpoints are available?
2 or 4 per CPU core. So it's not unlimited, but should be okay-ish. If you need more breakpoints than that, then you may have to look at a few other ways.
Okay, another question: are STM32 boards and SVD debugging possible?
Yes, that's a supported use case. So STM32, the Giga devices, chips. What else from the common ones? LPC ones also. So yeah, but STM32, so the blue pill, yes, that's definitely working.
Another question: can a break when a defined memory address changes its value?
I think that's not supported by the hardware break by the hardware unit. At least not for the M0. With the bigger MCUs, that's possible. I know what he means. So kind of a memory watch. I think the debug units of the M0 of the Pico are not configured for that.
Then a more general question, will there be a recording of this session?
Yes, there will be. So we will upload that sometime after on YouTube, I think YouTube.
Yes.
So you can have a recording of this one.
Yeah.
Oh, yeah.
Okay, then we can come to some announcements. You will see us again in the second part of our lab talk.
Yep.
Yeah.
First things first. So those who stayed until this point in the show, the giveaways. So we we have 10 Raspberry Pi Pico with header to give away. So these little boys, I removed the header on the back for this one. So 10 of those with a nice package USB cable, so you can start playing around with PlatformIO on those. The 10 winners will be drawn after the webinar is over and will be informed by our kind ladies that are in the background currently doing the administrative works. And that's it for the prize for this webinar. Next show coming up, that's the Elektor Lab Talk episode 2.
With us both.
Yeah, not every board is for surfing. So we'll have we'll have a little chat more about eval boards in general. What to use, what to pick, pros and cons, architecture. So a little chat, what a beginner or a more advanced user could pick out of those million boards that are out there, and which boards are currently still available and well priced.
And in 2 weeks exactly, but it will start on 6 o'clock instead of 4 o'clock. And we have the next show. It's the engineering insights. No, it's our first course from the Elektor Academy.
Yeah, adding to this topic,
the training,
So you get to know debugging techniques for Arduino from our colleague Stuart Cotting. He is in the field of debugging software development for a long time, so don't miss that out. Very, very interesting things you should know about to debug your code if you're developing with the Arduino or any Arduino-ish board.
So and on the same day, so you get Elektor double pack. First the lab talk and then the debugging techniques. And the next webinar is also with us.
This will be connect ESP32 to the cloud. And for that one, we have been informed we have also a set of giveaways.
It's nice.
That's the ESP at your side. Should be true. That will be the Make Python ESP32 development kit. So a nice starting kit with the ESP32. And it comes with a nice written little book with 46 projects. And at that webinar, we will talk about how to connect ESP32 to a cloud provider like AWS or Google Cloud or Microsoft Azure. So don't miss that out. And this means for the moment, we are at the end of this webinar. Some additional resources, if you like to read a little bit, the webinar site, have a look around of the past and upcoming ones. If you are going into the Cortex M0 field, like with the Raspberry Pi Pico, have a look at the shop, the definite guide to Cortex M0 and Cortex M0 Plus. Really good if you want to know where these registers R1 to R12 are good for and how the architecture internally of these CPUs work. So quite nice read. Little unhappy format for the book, but good read for that one. Also the Raspberry Pi Pico Essentials. Have a look at that. And I think not in the links, but also, as I said, this little kit. Have have a look at that. A really good starting point. You can use it with PlatformIO, Arduino IDE is not a problem, Python, good set of peripherals, good starting point, and it is soon available again, or it is currently available. So, and yeah, as you have seen, you can also use the peripherals with other eval kits. And at the end, may have a look at our easy newsletter so you don't miss out on the latest May spontaneous upcoming shows in the next weeks and months. Yeah. So we are in time, sort of. 1 hour.
Super.
Exactly.
Yes, we exactly met the point.
Time to enter the long German weekend.
Yes.
And yeah, for you also.
Have a good evening.
If it's the last day of your week,
yes,
enjoy your long weekend.
Yes.
Stay healthy.
Find your Easter eggs.
And see you the next time.
Yes. Bye.